Hello, everyone. Welcome back. I know we had a nice long spring break. I know we basically had 2 weeks off, which was great. I hope everyone had a wonderful spring break. I know the videos may not have as much use now since we are going to be in class 4 days a week. Every once in a blue moon, I may throw one up on a Friday. But I know a lot of us are maybe going to be out for different quarantines or other reasons. So just want to make sure I keep up with posting these videos. Maybe if you need to go back over something we did in class, I just want to make sure you have these available to use. So today, pretty quick, there is a little bit of vocab. If you want, at any point, you can always pause the video, get this down. A lot of this stuff you've kind of already seen before, especially 7.1 is all about adding and subtracting polynomials, which sounds kind of confusing, but you've done all this before. This is like one of the first things we did. It's basically just combining like terms, right? It's the very first thing we're doing here in Chapter 7. Chapter 7, I would say, is probably the most important chapter that we have left in the whole rest of the year. All right, we're going to go through Chapter 8, we're going to go through Chapter 9, but Chapter 7 is really, really important. It's got a ton of sections. It's got a ton of information. We go over factoring in this chapter. We go over how to solve these different types of equations, these polynomials that we haven't seen before. So just make sure from the very start you are paying attention. You're making sure you get all this information down because it's super, super important as we go throughout the year and as you go into geometry, algebra 2, all that good stuff. All right. So real quick, I'll just go over all of these different vocab terms. All right, a monomial, okay, mono meaning one. It's any expression, equation that just has the one term. Okay, so a number, variable, or product of a number and one or more variables with whole number exponents. Again, that sounds kind of confusing, but x is a monomial. Okay, it basically just means one term. I don't know why I wrote that way. Man, we all have to adjust getting back from spring break, huh? Okay, 3x is a monomial. 4x to the third power, that's all a monomial. Okay, it's a monomial when there's not a plus or minus sign in between. There's not two things being added or subtracted. It's just all basically one. You could think of it like one little chunk. Okay, so even something like this, even like 7x to the fifth, y to the seventh, right? It's got more than one variable, but it's not being added. It's not adding that y to the seventh. It's all being multiplied together. When it's all squished together like that, it means everything in there's being multiplied. Okay, that's what it means by like a product of the number and the variables. Okay, monomial is anything that's all being multiplied together at once. You could even have a crazy looking one. You could have like 12x y z to the fourth q. Okay, I could keep going on and on. When you're multiplying them all together, still a monomial. Okay, a polynomial, the like book definition here says a monomial or a sum of monomials. Okay, well, a monomial we know is one term, so this actually counts as a polynomial as well, but usually we don't really call it a polynomial. Okay, usually what we call a polynomial has at least two terms. Okay, it doesn't have to just be two. Okay, so something like 5x squared plus 6x plus 2. You're going to see a ton of things that look like that in this chapter. You've got multiple terms, okay? This is a term. This is a term. Remember, the terms are what's broken up by those addition subtraction signs. Okay, 5x squared plus 6x plus 2. Okay, that's how you know it's a polynomial. Okay, we've got special types. So a binomial has two terms, so 4x plus 7. Okay, we've got two terms. I've got 4x, I've got 7. trinomial, you can probably guess, has 3 terms. So let's say we've got 3x squared. I'm only using pluses for some reason. Okay, let's do minus 5x minus 4. Okay, I've got 3 terms. I've got this 3x squared. Here I'd probably call this term a negative 5x and then a negative 4. Right? Then we talk about the degree of a polynomial. I have degree of a monomial there. I got rid of that because it's more confusing and we don't really ever need it. Okay, degree of a polynomial is the greatest degree of the terms in a polynomial. We talk about degree with polynomials, we're talking about the exponents. So what is the highest exponent of all of these terms? So let's say I look back at this trinomial here. My highest degree, I'm going to highlight it here, is 2. Okay, so I could just say I've got a degree of 2. Right? If I have an exponent of 2. Okay, if the highest one is 3 or 4 or 5, those would all be the degree. You're not adding them all together, all right, or anything like that. You're just saying, what's the very highest exponent I see? All right, if your monomial is something like this, let's say you had 2x minus 5. Now, there's not really an exponent. You don't see an exponent, but remember when we learned all those exponent rules? If you don't see an exponent, it means your exponent is 1. Okay, so that one would have a degree of 1. And I really wouldn't ask you this question unless I really wanted to be mean, but maybe I will want to be mean. Maybe I give you a polynomial that's just a constant, just a number, plain number. There's no variables or anything like that. We could say, I really do have an x here, but it's just to the 0 power. Okay, remember anything to that 0 power is just 1. So this is like 7 times 1, which is 7. Okay, so my degree over here is going to be 0. Okay, that one's kind of tricky. You don't see that too much until you start to get into algebra 2 and all this complicated stuff. For me, as long as you know what I'm asking for when I say degree of a polynomial, that's really what I want. Right? And then standard form, if I say put a polynomial, put that in standard form, I'm really just saying put all the terms in order from highest exponent to lowest exponent. So if I give you like 3x minus 8 minus 4x squared, I say put that in standard form. I would just want you to scramble all those terms so that the highest exponent, then down to the lowest exponent. Okay, so start with that highest exponent. I don't want to forget these negative signs. When you're moving these different terms around and you have a negative, you got to remember that stays with that term, negative 4x squared. Okay, then the next lowest exponent, that's just my x term. So that's a positive plus 3x. Then my very lowest one, that's just your plain number. That'll always be the very last thing. So minus 8. Okay, so this one here is in standard form. Right, and then leading coefficient. So coefficient of the first term of the polynomial written in standard form. Again, it's a lot of words that really just mean when you write this in standard form, it's that very first coefficient. So of this one that I just showed you, that would be negative 4 would be my leading coefficient. And the way people try and trick you is I would ask, oh, what's the leading coefficient? And I would give you the equation. I'd give you the polynomial, in this format, and you'd look and you'd say, oh, it's 3. Okay? You can only decide what the leading coefficient is going to be when it's in standard form already. So just be careful of that. I know that's a lot of information all at once. It's just important in general to kind of know some of this stuff about polynomials. We're dealing with polynomials all through this chapter. The meat of what we're actually doing in this section is a lot easier than what it seems like from all this stuff I just told you. Okay? So again, this is a lot of information I kind of went over. Binomial, trinomial, we already know. Okay, degree is always that highest exponent. We just talked about all of that. Again, degree of a monomial is kind of weird. We're really just skipping over it because it's kind of confusing. Okay, what I care about is degree of a polynomial. Okay, so let's look at something like, let's look at number 12 over here. It's asking lots of questions about this polynomial. So it's saying, write it in standard form, then find the degree and the leading coefficient, and then classify it by the number of terms. So it's asking us all this stuff. Again, I don't want to get confused and say, oh, well, I know the leading coefficient. That's the first coefficient. That's going to be 1. I can't decide that yet because I don't have this in standard form yet. Okay, so that needs to be the very first thing I do. Okay, so polynomial in standard form. I've got my highest exponent right here. I've got f to the 4th power. Then I have f squared. I haven't learned my lesson. I need to mute my Apple Watch while I do these. Okay, so plus f squared. And then very last one, I've got that minus 2f. And again, I'm always being careful to keep my positive and negative signs attached to those terms. Okay, so the degree, I remember, is my, how many, not how many exponents, what's my highest exponent? So that's always easier after you've put it in standard form because it's the very first one. So I have a degree of 4. My leading coefficient, all right, that's the coefficient that goes with this highest term. I don't have a coefficient. I know that means my coefficient is 1. So my leading coefficient is 1. Then it says classify the polynomial by the number of terms. That just means, is it a monomial? And I just spelled monomial wrong. I'm on a roll today. Monomial. Okay, does it have 1? Is it a binomial? Okay, which is 2. Or is it a trinomial? Does it have 3? Okay, so I have 1, 2, 3 terms. It is a trinomial. Okay, so once you understand, once you know this vocab, all this stuff is pretty easy. All right, just make sure you're not mixing different things up. Don't tell me that this has 4 terms, for example. Make sure you know, okay, degree is the exponent, leading coefficient's the first coefficient, and then when you're classifying, when it's asking about that classify bit, it's talking about what type of polynomial do we have here. Okay, so it's easy enough. Then really all it's asking us to do, other than kind of that vocab stuff, is it wants us to either find the sum or the difference of these different polynomials. Okay? Again, this looks like something that almost should be difficult, but this is really, it's almost like the second assignment we did for this whole class where we were combining like terms. Okay? So I'm going to do like the very hardest problem in this whole section, number 16. Okay, I've got 2 different polynomials here that I'm adding together. Since I'm just adding them, the second one doesn't change. None of the signs or anything change, so I'm just going to write it all out. 2 squared plus 3t cubed minus 3. And then I've got this positive 2t squared plus 7t minus 2t cubed. All right. So all I need to do here is combine like terms. Okay, I'm always going to remember if I have different exponents, that's not a like term. I can't combine over here this t squared and the 3t cubed. Okay, those aren't like terms because I have different exponents. But I'm just going to start from the highest exponent and go on down and just keep combining those like terms. Okay, and some people have different like things that they like to do, like circle all the squared ones or box all of the. I don't always do that, but sometimes what might be helpful if you have a ton of terms like this is as you have seen each one and you've done the math for each one, you might want to like cross it off or underline it. So I'm going to do that as I go. Okay, so 3t cubed minus 2t cubed. Those are the only two cubed ones. So I'm going to add those coefficients. I have 3 and -2. Okay, make sure you're just always careful with that. Don't say 3 plus 2. Okay, it's not 5t cubed. You're just going to have 1t cubed, which is just t cubed. Okay, then the next one, we're going t squared. All right, so I've got 1, 2. So, okay, I have 1t squared and 2t squared. Don't just end up with t squared. If you want to write in the 1, go ahead and do that. So you remember that's 3t squared. Okay, and notice that the exponents don't change. Sometimes people will want to like add the 2 and the 2 and get t to the 4th. That's not what you're doing. All right, you're keeping those exponents the same. Okay, so I have 3t squared. Looking over at just my t terms, and I just have the 1. I just have 7t. So that's just going to stay the same. Plus 7t. Right? And then -3, I just have the 1, so -3. And that is your final answer. There's really all there is to it. Okay? It's just combining like terms. Don't make it more difficult than it needs to be. Sometimes you look at these equations just at the start and it kind of seems like it's going to be more difficult, especially when you're adding these different polynomials. Okay, when you've got an addition sign in between them, that's really all there is to it. You're just adding all your like terms. All right, let's look over here. Let's just do one where we're finding the difference. Okay, difference just means we're subtracting instead of adding. Okay, so again, let's do the very hardest one because I think we're going to look at these at first and maybe think, oh my gosh, there's so much math to do here. But again, it's really just combining like terms. All right, the only thing with difference that's a little bit different, you have a negative right here in front of that parentheses. Okay, so think of it almost like you're distributing. That's really what you're going to do. If you want to think of it like a -1, you can. And you have to think, well, that -1 is going to everything after it in these parentheses. It's going to that 5k to the 3rd power. It's going to the 7k. It's going to that -3k squared. Okay, I'm going to make that look more like a 1 and not a plus sign. Okay, so I like to rewrite this. Some people, like they'll just rewrite the little negative signs over top. I would usually probably make a mistake if I did that. I just like to rewrite everything. Okay, so I'm going to just rewrite the first one, k squared plus 6k to the 3rd minus 4. And then the second one, all the signs change. So -5k to the 3rd minus 7k. And then, okay, -3k squared is going to change to +3k squared. Okay, now this is just like the problem we just did. I'm going to start with the highest exponent because that's the easiest. Then your answer is just automatically in standard form. Okay, so I'm going to look. I don't have anything to the 4th power, so it looks like 3rd power is my highest exponent. I'm going to say, okay, well, I've got this 6k to the 3rd. I've got -5. I don't have anything else. Okay, I could have 3 or 4 terms all to the 3rd power, but in this one I don't. I just have 6 minus 5. Okay, so that's 1 k to the 3rd. I'm just going to write that as k to the 3rd. Okay, then I've got squared. I've got k squared. I've got 3k squared. All right, so just 2. Again, I'm not forgetting this one has a 1 out in front. Okay, so 1 plus 3, I get 4k squared. And I'm not adding those exponents. Then just my k term. Well, I could have more, but I just have this one right here, this -7k. And then any constants, and I actually just have the one, that -4. Okay, so really, this is something we've been doing since basically the first part of the year. Really shouldn't give us too much trouble. Okay, just be careful with your exponents. Be careful with those negative signs. If anyone ever messes up these problems, it's always just forgetting a negative sign somewhere, especially with these difference problems. It's so easy to forget this first step where you distribute out that negative. So just be super careful with that, and you should be good to go. All right, I'll see you guys later.